So there's things in this chapter that you have to memorize. There's things in this chapter you could memorize, but personally I don't. I just sort of reason them out. So you do need to memorize what slope's about. So a formula for slope is changing y over changing x. For this particular graph, I would not necessarily memorize what the slope of a distance time graph is, because I can just reason it out when I need it. Okay. On this, the y-axis is no longer labeled a y, it's labeled distance. The x-axis is no longer an x-axis, it's now time. And at some point prior in the year, you memorized an equation where distance was divided by time to make speed. Or if you prefer, velocity. So anything up on this graph that I'm talking about slopes, I'm talking about speeds. Or if I'm talking about speeds, I'm talking about slopes, as long as this is what the axes are labeled. You don't necessarily have to memorize that, but you can if you want to. Another synonym phrase for slope is rate of change. A slope is a rate of change. A rate of change is a slope. Those are interchangeable words, phrases. So if I do a distance graph, somewhere in your memory you have rate of change of displacement in your memory banks. The rate of change of displacement was velocity, and it still is. So you don't have to memorize all this stuff. You can, but you can reason it out when we need it. In the homework, they're going to draw you a lot of mini graphs like what you just did on the back of your quiz. And then there's going to be one that's like a crazy, ridiculous super graph that's a combination of all of the mini graphs. So A, B, C, D, E, F, G, H, something like that. Where one of the homework questions in the chapter review says, describe all the different kinds of motions that are happening here. So if we just focus on the part from A to B, that is one of your graphs that you just made on the quiz. Which graph was that? That is increasing velocity. Because in this world that we're talking about, as long as we're on this picture, slope equals velocity. Or speed, whichever word you like. Why is this an increasing velocity? As you travel, it gets steeper. So that is an increasing velocity from A to B. From B to C, is it getting more steep or less steep? Less steep. So this is an area that has decreasing velocity. From C to D, you have zero velocity. From at D, what happened? Change direction. Okay, so right here, we had a change of direction. Because instead of going up, the rest of the graph is going to be going down. Do we have another zero velocity zone coming?
Yes.
From F to G. This is another area right here with zero velocity. We did not yet have anything about what type of velocity. We did increasing velocity, we did decreasing velocity. What other type of velocity did you quiz on the back?
Constant.
Constant velocity. Do you have a zone here where it's constant velocity? G to H. This is constant velocity because it's not getting steeper. It's not getting less steep. It's just a totally straight, constant slope line. That is constant velocity over there. As we move from D to E, is this getting steeper or less steep? Steeper. So this is increasing velocity. Imagine riding your bike. Riding your bike, you're pretty comfortable, it's not that steep. Now you're continuing to ride your bike. Right about here, you're getting kind of scared because it's like you're dropping off the face of the earth. As we travel this, is this getting steeper or less steep?
Less steep.
That is less steep. So that is decreasing velocity. There's a homework question like that where they have all these little mini chunks and they want you to label what each mini chunk is about. There's also some homework graphs where they might only give you this piece. What was that piece? Decreasing velocity. So there's some easy graphs. I think they're at the end. And then there's one like crazy ridiculous graph, but I think that one's toward the beginning. So just be on the lookout for that. There's also synonym phrases you could use and still be right. Instead of saying you have zero velocity, what's another thing you could say?
Rest.
You're at rest. What does that mean?
Not moving.
Not moving. That's all correct. Any of those things that we just said there would all be correct. Increasing velocity. What does it mean if you're increasing velocity?
It's getting steeper.
Yeah, it's just in the real world. If you have increasing velocity,
I'm going faster.
you're going faster. What's a physics word for going faster? Accelerating. A decreasing velocity means you're going slower. A physics word for that. Decelerating. So any of those descriptions are appropriate. You pick which one you like. So if one of you says zero velocity and the other one says you're at rest, that all means the same thing. Question about that picture, crazy picture, which will have a bunch of offshoot simple pictures. I think in last night's homework, they had a straight line and asked you to find the slope, or maybe it's the next homework, or maybe it's both, I'm not sure. If you have a straight line and they ask you to find the slope, how can you do that? Yeah, but you first have to have 2 points. So you pick 1 point on your graph, you pick another point on your graph. Does it matter which 2 points you pick? No, not if it's a straight line. Pick any 2 points. Any 2 points you can locate, and you find the slope. So if they ask you to find the slope of a line, just find 2 points and do that. Practice test answer that I gave away yesterday. Does anybody remember how I told you you'd have to find the slope at 1 point?
Something with a tangent.
Something about a tangent line. We can draw a thing called a tangent line. I think the question was actually, how do you find the slope of a curve? And it's to find the slope, or to draw a tangent line, find the slope of a tangent line. What a tangent line means is you're only going to touch 1 point. So if I have a curvy thing going on, the slope is constantly changing. Like at the beginning, that's not very steep. At the end, that's getting very steep. In the middle, it's like sort of steep. So everywhere along this line, the slope is doing what? What was our word from over there? Increasing slope. We have an increasing slope. It started off close to horizontal, it ended up close to vertical, and it's everything in between. So I believe there's one homework question in this chapter review, and this will happen once in this year, because to do this, again, involves calculus. If you're going to do curve stuff, it would have to be calculus on a consistent basis. We're going to do one little mini algebra move to do this one time in a simplistic way. A tangent line means you draw in a line that touches just that 1 point. But it like approximates the slope. Right here, the curve for right here is about this steepness, right? Over here it's steeper, over here it's less steep, but here it's going just like my hand is for a minute. So I'm going to draw a full line that kind of mimics where my hand is. You'll need for one problem to use a piece of graph paper, because instead of finding the slope of this curve, I need to draw in this one line, which right here, see how they basically overlap? Like the curve and the line are about in the same spot for that brief period of time. But the line keeps going. The line that you drew, look for somewhere that on your graph paper you clipped a corner. So like right here by accident, I clipped that corner right there. I didn't clip any more corners. But if I had a piece of graph paper Sooner or later, would this line have to clip another corner of a square? Somewhere, it would have to. And now, just like we had with our 2 points here, do your normal slope. Okay, so you would need like a ruler and a piece of graph paper to draw this line and look for any 2 spots where it did clip a corner. Do the slope on those. That's how you would do that. That's a one-time deal. You only have to do that once in your entire life, most likely, unless you take calculus, and then maybe you're going to do that a second time someday before it gets replaced with other means. Question about that concept? Here's something you'll do a bunch of. So if I give you a speed graph, and I want the distance, does anybody have that from the word stuff? How can a speed graph give you a distance?
It's the area underneath.
It is the area underneath, which you could either memorize that, or you could try to reason it out. If you have speed and you have time, if you have velocity and you have time, what equation have you done before with v's and t's in it? Like what equals what with v's and t's? S equals v2. So velocities times time make distances. If I'm taking this stuff times that stuff, I'm finding the area of shapes. So if I ask you how much distance you have in there, you just have to find the area of that triangle. So 7th grade and or geometry flashback, area of that? Correct. How do we do areas of triangles? People are muttering, I can't hear.
Something with a half.
Something with a half, yes.
Multiply stuff.
Multiply what stuff?
Base and the height.
Okay, we do the base, which is
10,
10, times the height,
10,
which is 5, thinking in our mind now, 50. Cut it in half for triangles,
25.
and that will be 25. If I want to do the distance covered between 10 and 40, that's going to be easier because now we have a rectangle. What's the area of the rectangle? Okay, so how much is the base? 30. From 10 to 40 is 30. Times 5, 150. If I asked you for the total distance, you'd say 175, because we just add the pieces together. If I wanted to go again, and this is 60 now, let's say, the distance I just covered in there, we would take 20 times 5 is 100, 100 and a half is 50. That will happen in the chapter review for sure. That's on the test too, for sure. There's sometimes we need to do some areas. There's more times probably you need to do some stuff with slopes. But they're both in this to some degree, tonight and indoor. 30 wide, from 10 to 40, that's 30 wide, times 5 high.
No perimeter stuff.
Nothing with perimeter. Perimeter is worthless. Areas can do some things, and slopes can do some things. Question about this to help you do tonight. Most of this is stuff you haven't done yet on your own. This is like reviewing a little bit of your skills you'll need to do the tonight. Okay, let's look to the 1 to 7. 1, you're making a table. Like yesterday, I did a sample problem that made a table.
Should I stop recording?
He can listen in on this too if he wants to. Doesn't hurt anything, I guess, to record this. Just have to let it roll. For 1 yesterday, I made you a table. I think I went like 1, 2, 3, 4, 5 or something. They made their table to go from 0 to 20. So whether you made the full table using every number from 0 to 20 or not, or if you shortcutted it the way they did, where they did in the margin like 0, 1, 2, 3, 4, dot, 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 we get the point, and then resume for the last answer. I'm fine with either of the approach of the full table or the like little cheat that they did. But 1 has answers all in the margin. Does anybody need me to do something more with 1 than you had access to the answers in the margin? 2, ABC. Do you have to do anything fancy to get distances from a graph that's a distance graph? No. You just have to read the numbers from the, if it's a distance graph and you want a distance answer, you just grab numbers from the y-axis. So all number 2 is grabbing the right number from the y-axis. And if it's going from one spot to another, though, I guess the hardest ones are going to make you find 2 numbers and do what to the results?
Subtract.
Subtract. You're going to have to do a little bit of subtracting on 2 if it's going from here to there. But we're looking only at y-axis giving us answers. They're giving you like x-axis places to look. You need to get some y-axis numbers going. Anybody 2 have a trio of answers you feel good about?
100, 0, 200.
I agree with 400, 0, and 200. Does anybody need more help with 2?
Yes.
Okay, so if they want how far it travels between, let me go from 70 to 90, because that's not a question they asked. So I'll make up my own question. If they want how far it traveled from 70 to 90, you would look up 70's distance number, which is 400. You see how 70's distance number leads you to 400?
Yeah.
And then you'd look up 90's distance number, which leads you to 200. So how far it traveled in that time is 400 minus 200 is 200. Okay? Anybody need a little help with 2?
So for something like B,
Okay.
when you get 30, would it be 300?
No, you're gonna follow the graph to find 40, how high it is.
Oh, and then subtract it from 70.
Find 70, how high it is. Subtract the results.
Instead of subtracting just 70 and 40.
Correct. The 70 and 40 are only there to guide you to a certain height on the graph. And you're gonna subtract the heights from the graph. Is that okay?
Yeah, so thank you.
Anybody 2? 3 is in the margin. How did you find 3 other than cheat? If they give you a distance graph and they want speeds and you're not a cheater, how do you find them? Divide what by what? Distance divided by time. You're basically finding the slope. We're finding slopes. So on 3, A to D, you're finding slopes. Which of those slopes can you most easily just eyeball without mathing it? From B to C. Why B to C?
0.
It's 0. Because at some point in our algebra careers, we memorized that this has 0 slope, just like this is
No slope. Oh, constant.
positive, this is
Negative.
negative. What was no slope?
Straight.
That's straight up and down. That's not going to happen to us. 4. I stumbled right into the question. We just had this conversation. So what's 4 about? It's negative. If from A to B is considered positive, from C to D would be considered negative. That's all 4 was about. 5, they had you make a table. 5 is basically just a continuation of 3 and just putting the numbers in a table. You had to find a bunch of slopes. Find a bunch of slopes. They were all in number 3, 10s, 0s, and 20s. So on 5, you have a bunch of slopes that are all 10s and 0s and 20s. Some of them negative slopes because they're coming downhill. If you graphed 6 right, it would look like a yesterday graph. What weird graph did I graph yesterday that is what 6 is going to look like? Yeah, it's like a bunch of
Lines.
making kind of like steps, or like a step here, a step there, a step here. You're going to get a series of steps on 6.
Do they connect, or do you just leave them?
Say again?
Do they connect?
No, you don't try to connect them, because if you did, you're in like the no slope world. You just do the steps, leave them alone, don't try to connect them vertically. 7 is all in the margin again. I think 7 was basically 1 again, wasn't it? I mean, 7 is basically like, again, you make a graph. 7's graph looks like 1's graph. What word would you use from our graphs to describe both 1 and 7's graph?
Constant.
Yeah, we could do constant velocity, true. If we were thinking not about the back of the quiz, but the front of the quiz, which one from the front of the quiz is it?
Direct linear.
Direct variation.
Oh, direct.
direct variation or constant speed, whichever side of the quiz you're thinking about. Does anybody need more guidance on 1 to 7?
Number 3, how do you get C?
C, you're going to compute the slope from 70 to 90. So the slope is how much did it change this way? So from C to D, how much change did you get this way?
3.
Disagree. In the y direction, looking at the y-axis. From C to D, how much it fell from?
Oh, 200.
You fell 200, yes. Then from C to D, measure it this way. How much across has it traveled?
30.
Disagree.
20.
20, agree. So do the 200 divided by the 20, and that's where they pulled the 10. You could argue for negative 10, because it is going down, and I would actually say that's probably better. But again, it's because they dodged the conversation about vectors and scalars and negatives and directions and things that it leaves us in an awkward position right now. Because what they did on 3, they left 10 and 20 as positives. But when they made the table on 5, they turned them into negatives. So they're kind of like living with a foot in both worlds right now. They just kind of do what they feel like. I'd rather just make them negatives because they're downhill. Anybody else? Something about the 1 to 7s, yeah?
D on 3.
D on 3, same thing. You're going to do the finding the slope from like the D line to the final touch line. You'd have to measure how far it went in the y direction.
So
Which,
would it be 200 minus 200 as it goes?
no, because it starts off at a height of 200, it ends up at a height of 0.
Oh, so 200 minus 0 then?
Correct. And then in the x direction, it moved
10.
10. So do the 200 divided by the 10.
Oh,
And it should be a higher number because it got steeper. So just looking at your eye, from C to D is steep, but from D to the end is even steeper. So it should give you a bigger number, and it will. Other stuff, 1 to 7, that I can try to illuminate anything for anybody.
5 for the table. If
5.
we're using 3,
It's using 3's data.
so what does that mean?
So like they want you to count off by tens. So in the table there in the margin, they counted by tens, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. They did those because those are the x-axis numbers. Then in part A, you had a 10. On 3A, there was a 10. So if you look at the picture, there's a straight line from A to B. The whole way from A to B, the slope was always 10 on that path. So the first square is 10, the second square is 10, the third square is 10, the fourth square is 10. So they start off their table rattling off 4 10s in a row because there's those first 4 slots.
It doesn't change.
It didn't change. And then in the 5th slot, it changes across that top, we're 0 slope here, and that filled 3 squares. See how there's 3 squares worth of
Yeah.
0 slope?
So
So when they built the table, they went 0, 0, 0. Does that make sense? Anything else on 1 to 7ers? If you have those, make sure your name's on them somewhere. We'll shoot those to the window. We'll stop our record. Tomorrow, not a quiz. Tomorrow, we'll spend a good bit of time talking about the chapter review. The chapter review is going to take you some time. If you get a question you hate, skip it, go to the next question. Because like I said, the easier questions are toward the end. So don't like flip out on like number 3 is big or something. The easier questions eventually come.